Good morning. I'm Allison Meyer. Thank you for joining us for this month's MEYERTech webinar. We will be continuing this webinar series every other month to share insights into the many ways MEYER is using technology to troubleshoot, solve problems, and develop solutions in our industry. This month's featured speaker is our very own Noel McKim, MEYER's engineering manager. We are very fortunate that Noel has been with MEYER for 9 years and is a wealth of knowledge. Noel's background is in mechanical engineering, design, and software programming. Noel, along with MEYER, holds several patents in the field of wellhead lubrication and automation. Please feel free to send us questions throughout the presentation for Noel to answer using the chat function here. So this month's webinar is going to be slightly different. Rather than doing a presentation, we've had a list of questions come in, and we're going to ask Noel kind of like a live Q&A session. So Noel, the first one is, when is the best time to grease valves?
Okay, so first, I think the most overlooked time is at the beginning of the frac. The mindset is always these valves came right out of our shop. We sent them out there, but when I rig up, if I'm out on a pad, I rig up. When we rig the equipment, I always tell frac watch, go ahead and grease those valves just like a maintenance grease then. And then when they're starting the first stage of the frac, I want to do the same thing. I want to go ahead. It doesn't take a whole lot, but when they go in, they do any kind of acidizing, that's very detrimental to it. Transportation, or if the shop maybe didn't fully grease, and then every time you function the valve, you're going to lose grease. And many times in rig up, to make sure hoses are right, you've gone through multiple cycles with the valve, and you've knocked grease out. So that's the most overlooked and worst time to not grease a valve is in the beginning. Other than that, and we'll probably talk a little more about this later, I also go in with best practice. We'll talk about some different programs. We do a pressure base, which will allow you to grease during the frac. But I still like to, when you're starting, before you go into pressure base, I like to fill those cavities. The theory is keep the grease cavity full to never allow a place for sand to intrude into it. So a little bit of grease very often is always the best policy in our opinion.
Okay, and what causes the valves to lose grease?
Multiple things can cause grease loss. High velocity, so higher pump rates will actually form like a Venturi effect, like a carburetor, where we actually form a suction and you'll lose grease. And there's a lot of times that's kind of been looked in the past. Grease profiles have worked for decades. People have grown up, started out as a hand, and then work their way up to supervisor, sometimes owner of the company. And they say, well, this is how I greased when I was out there. But, they were doing flow rates of 40, 45 barrels a minute. And now you're seeing, 130 approaching 140 barrels a minute. You're going to take a lot more grease than you used to. So you have to pay attention to your frac design and to your stack. 80 barrels a minute in a 7-inch stack is not a high velocity. 80 inches in a 5-inch stack is a high velocity, and you're going to have to grease more. We mentioned earlier, every time you function the valves, particularly the initial function, you can lose 2.5 pounds of grease in a 7-inch valve just opening it up to begin the stack. That's a void we're seeing can get in. And then when you're doing flowbacks, you can get extremely high heat, particularly in some of the Haynesville areas, and that high heat can actually cause a thinner viscosity and increase some of your grease. So there's a lot of things, and I think one of the important things is to always look at if you have a program and it's working well, and then you have a well where you have problems, is to do the root cause analysis and see what was different on this pad than the other pads. Did we change flow rates? Did we change sands? Did they change chemicals? And sometimes you really have to be persistent, but those are the answers that are going to make you more successful down the road.
And should our grease program change with fluctuations in temperatures?
So obviously, outside environmental temperatures in North Dakota, you're going to run a much thinner grease in the wintertime than you are in the Permian in the summertime. And everybody's kind of taking that into account. Um, Again, you have to kind of watch uh, that thinner grease that you're pumping so that you're able to pump at 10 below. Your wellhead pressures are much warmer, the heat of the frac fluid and everything. So you could sustain higher grease losses due to thinner, that viscosity breaks down and gets thinner on there. And then, like we talked about on the last question, like a high heat flowback, which really is typically a concern that tends to be at the end of a deal and more of a production. But those things can cause lower viscosity and higher grease losses. And you may need to allow for more time for stage based greasing in extreme cold, or tent and tarp to keep heat, to keep your grease from getting so cold.
And are you able to run splitters?
So we've had many customers have tremendous result with splitters or bridles to apply the grease to both ports on a large bore valve. When people started with it 6 years ago, our initial response was it was going to lead to valve failures. The grease would take the path of least resistance, but the valve cavity does a really good job, especially when functioning, to even itself out and allow that grease to go where it needs. So we basically see it pretty much a standard on all large bore valves now to have splitters. We do have a few customers that will put an isolation valve on each end of the splitter or the bridle. So when you have a longer maintenance shutdown, a pump's down, or a lubricator's down, where they can isolate and they can manually put it in each side without having to rig up or rig down, and give you a little better feedback to make sure. But that's probably 10%. It's a good practice, just not widely accepted.
Okay, and does the type of valve affect how much grease I should use?
So your different valve types, as well as the condition of your valves, can can definitely have an effect, and a lot of that comes from your field knowledge. Now, and valve size. 7-inch valve, a typical 7-inch valve can take 45 pounds of grease. A 5-inch smaller, 3-inch much less. There are some of these low grease valves that people have put out, a 7-inch valve with as little as 7-inch valve might have as little as 7 pounds of grease in there. But the low grease valves, you have to be even more careful. If you lose 4 pounds in a regular, 7-inch 15 of, be it ValveWorks, Best Way, through bore, you've lost about 10% of your cavity. If you lose that in a low grease valve, you've lost over half. And if you get sand in there, you're going to sand off. So low grease valves for the same size actually require, in our opinion, more attention and better care, even though there's not a lot of time associated with it. So you do need to know your valves and watch your success rate. Valves that are further along the lines as far as extreme tolerances, a valve that's got some wear can take more grease than a valve that's just come through machining, or a brand new valve as well. So that's where our Gen 3 we feel like is a very powerful tool, gives the operator the ability to track how much grease is going in each individual valve on there. And you could even compare it. Lower master will take more grease than a crown valve, even though they're the same size. They take more abuse. But if your lower master on well 1 is taking a lot more grease than your lower master on well 2, it's something maybe you keep an eye on, maybe you apply more grease, maybe you do more maintenance grease cycles to make sure you get through the job without any downtime.
I think you kind of already touched on this, but does the size of the valve change the program?
The size of the valve, like we talked about, can change the program, but it can be. We also talked about the velocity and the Venturi effect. So, in a regular, if you're running a 5-inch stack versus a 7-inch stack, both at 75% of recommended flow rate, the 7-inch stack will take more grease in your program than the 5-inch stack would. However, when you start throwing in like Venturi losses, a 5-inch stack at 80 barrels a minute could actually require more grease than a 7-inch stack at the 80 barrels a minute. So it's kind of a two-part question. It goes back to addressing those other factors like flow rates that you're faced with.
Okay. And can valves be greased in full open or closed?
So the valve manufacturers, and I think we might have a couple of them in on the chat, and feel free to send us a message if you want to chime in here. I know that, standard practice was always half open, half closed to prevent from pressure locking the valve. And on manuals, I believe that's really quite critical. What we've done to try to eliminate that, the success on hydraulics has been pretty good. In our automated programs, we're putting pressure caps in to prevent you from putting too much pressure to pressure lock. And I haven't heard of anybody pressure locking any of the hydraulics on there, and very, very few in the manual. On the pressure base, because your system is all equalized, both sides of the gate and seats and everything else, we really don't feel like, unless you're seated all the way back up against that back seat, so long as you back it off your half turn, I don't think there's any issues, because the valve's basically kind of self equalizing, and the grease pressure that you're putting in is really just a few hundred pounds over what you're seeing in the well bore.
Okay, and what is the best place to read pressures?
So if you're running one of the automated programs, we build a couple systems. We build our Gen 3, which is our top fully automated system, and that system is going to read pressure at each individual each individual stack. The best way to do that, if possible, is some sort of a companion or pancake flange with a port or off of a goat head. And if you can get away from your sand flow, if you can get up above, if you're coming in at a cross and you can get up above the cross, you'll have less problems with transducers and sanding off than if you're lower. You definitely don't want, the easiest place for people is to put it on the casing head, but you put it on the casing head, you're going to sense pressure all the time. So you're going to lose a lot of your automation advantages, and you're also going to have more problems with transducers, and it's more difficult to replace the transducers. If you go with our mid-grade automated system or semi-automated, our Spiderling system, you only have one transducer to read treating pressure. And so on that, it depends, but basically you're tying in anywhere from your large bore or missile manifold up to your beginning inlet on either your zipper manifold, bridge manifold, or like Javelin disconnect system, so that you're going to read whatever frac treating pressure is. It will not be well specific.
And do you have a recommendation of what type of grease should be used?
So we get this asked a lot. We have, at this point, not made any specific recommendations on grease. We will make kind of an exclusion. We see a lot of particularly pump failures with the very thick, the peanut butter style greases. Pumps gall up. They're very slow. I know a lot of valve people love them because once they're in the valve, it doesn't want to come out. But we feel like getting a little bit of grease in very often and keeping that cavity from ever occurring eliminates the need to use that peanut butter grease, and you have a lot less failure of some of your components. There's also a lot of very high tech greases that encapsulate frac sand. Some people are telling us that while it encapsulates it to keep it out, if you ever do allow a void to form from bad practices, that it's going to encapsulate it in the valve and it's that much harder to flush or get out.
We had a recommendation come in on the type of grease.
Okay, so yeah, so one of the people on the chat is saying that jet lube grease is by far the best grease on the market, and we have tons of customers that are running the jet lube and swear by it, and it is a very reasonably priced grease. Seems to be very consistent from batch to batch. So yeah, certainly would not argue that point on there. We think there's some other really good ones. A lot of our customers are running, particularly on the pressure base where they're greasing a lot, or running the graphite or the jet lubes. So
okay.
But thanks for that feedback.
And what do I do if my valve starts to sand off?
Okay, so first, the sooner you can do something about it, the better. And the main thing you want to do is displace the sand. And the majority of the time that can be done just by kind of doing a maintenance grease over grease cycle on it to displace it. The nice thing about the spider system is you can do that during the frac, and you can do that as soon as you're shut down. Of course, the wireline hates grease, stuck tools, so I would not do it while wireline is in the hole. But otherwise, as soon as you can get grease to knock that sand out, and if you have the ability during the maintenance cycle to cycle it a couple of times and then grease again, that will usually do the job. I'd pay a little extra attention to that valve over the next few stages, maybe get a little extra grease in just to kind of help work it out. Severe cases, people are using, when you have a maintenance shutdown, hooking up a flushing unit, high pressure, heated, that you can even put solvents in to dissolve the grease, flush all of that out, and then basically replace the entire cavity, right? 30, 45 pounds, whatever it is. But those are pretty few and far between, especially if you just stay on top of your greasing. During the stage, you really shouldn't have a major problem.
Is the pump rate important?
The pump rate is very important. And I think it's overlooked. It's why I harp on it so much. It's funny, right? Everything's pushing to maximize how far can we push this. And so we've helped people, and they've set up grease programs. They've run our Gen 3 system. They pumped repeatedly at 130 barrels a minute where they were having multiple failures, and they eliminate the failures on there. So the next thing that happened is, well, if we can do 130, we can do 135. And so you can go, we've seen people go 4, 5, 6 pads at 130. You go to 135 and you start washing out iron, you're having valve failures. So even when you're maxed out, small changes can make big differences. So that's something to always keep in mind when you're bidding jobs and when you're setting your programs. If they're increasing the demand and you knew you were having problems before, you can always bump. Grease is a whole lot cheaper than NPT and valve parts. So you can always bump that greasing up a little bit. Always tell people too, if you're not sure, if you're doing 50 stages on a well and you're not sure, I'd grease heavy for the first 45 stages, and then go ahead and cut it back to what you think you could get away with. And when you tear down, see if you've got sand in there. And so you can start high and work your way back. Just always do your experimenting at the end of the job, where you're not as likely to have an MPT or a valve failure.
Okay. And is there a recommendation on the size of air compressor that should be run?
Sure. So forever, the compressors that were run were small, 15, 20 CFM, 10 horsepower. And those units are still great for production and, production flow back and things that are non-time critical, where you're not doing a lot of greasing or you're not doing it very often. Frac, where everything is so critical, and even in our opinion now, shop, we think 80 to 120 CFM, which is going to tend to put you in a 20 to 30 horsepower size compressor, will make huge differences in the amount of time that you're able to grease.
Can you daisy chain the MEYER spider manifolds?
Yes, you can. The largest I've seen personally is 6 manifolds daisy chained together. We do recommend, to where possible, to bring your pump inlet in the center. That way you're limiting your back pressure line loss and kind of equalizing. So your first and your last spider are as close as possible to feed rate and back pressure.
And how far away from the well can I be without affecting greasing?
So every foot creates more back pressure, and there's a lot of other factors that are in. We designed the spider system with 150 foot of hoses in mind, from the manifold to the unit, including your bridles and that sort of thing. So the back pressure, the engineering, the internals are set that way. We've seen 250 foot and still had pretty good production. We've seen copycat systems have issues as short as 30 foot. So.
And how does the sand mesh affect the greasing?
So sand can often be a wild card. A lot of the sand, I heard one study that 95% of sand that's being used doesn't meet the API spec that it's certified to. So you don't know for sure what you're getting. Obviously, sharper sand profiles will be more abrasive, and so require more grease, more critical to keep it out. But basically, the finer the mesh, the more likely it is to get places where you don't want it to be. So finer meshes, higher concentrations of sand in the mix, higher pump rates, all things that would lead me to increase grease to try to keep it out.
And how do chemicals affect grease efficiencies?
So chemicals are one of the toughest things for you to tell. They're very often kept somewhat secret. That's their competitive advantage that they'll pump in. And so very often you don't know what's being pumped or when it is. When you do know, if they acidize a well, I would always recommend greasing after acidizing. And it goes back to when things change, right? Most of the greases, right? Like, we talked about jet lubes earlier. They've engineered that grease for your standard frac conditions, standard frac chemicals, not to be broken down by low concentrations of hydrochloric acid and the other stuff they're going to put in there. But if something changes and you start having failures, it's something to look into. And if you do know they're having problems with the well, and often you can tell company men, right? It's like, I know you don't want to tell me what you're using, but if you're having to pump something different down the well, let me know so I can increase my grease, for the next couple stages.
Well, no, I believe that's everything, unless anybody has any last minute questions to add, which I haven't seen any additional come in. So thank you, Noel, for sharing all this with us. I learned a lot. Don't know about anybody else, but in closing, thank you all for spending this time with us. If you have any questions about our greasing practices or our spider manifolds, please feel free to give Noel a call here at the office or comment on the video after it's posted, and we'll get back to you. And we'd love for you to join us in August for a live demonstration kind of the spider and talking through it at OTC with everybody. Oh, wait, one more thing just came in. Graco recently released a high pressure pump that has 10 times the life in pumping peanut butter grease and uses around 100 SCFM air.
Okay.
That's gibberish to me.
Oh,
Noel probably knows what you're talking about.
Yes. Yeah. And we have seen, so Graco does have a new 250 to 1. So comparable in rating and flow sizes and stuff to the Lincoln 8-inch, the large Lincoln pump. So.
Well, we hope all of y'all can join us at OTC in August, and we look forward to seeing all y'all. Thank you.